In this problem, we will compute the reactions in this structure. The first step is to identify which reactions do we have. Since these are both hinge supports, both of them have an horizontal and a vertical reaction. I'm going to assume that the horizontal reactions are to the left and the vertical reactions are upwards. And I'm going to give them some names. Now, the main difficulty in this problem is that we have a distributed force of 6 kilonewtons per meter, which is neither horizontal or vertical. The first step is to calculate what is the resultant of this force. So each beam has a length of 3 square plus 4 square meters, 5 meters. And the resultant is therefore 6 kilonewtons per meter over 5 meters, meaning 30 kilonewtons. As a result, this distributed force is equivalent to a force of 30 kilonewtons here and 30 kilonewtons here. Now this force is neither horizontal or vertical, so it's useful if we can decompose the force into horizontal and vertical forces. This angle here, alpha, is the angle whose tangent is 4/3. The cosine of the angle is the adjacent side, 3 meters, over the length of the beam, 5. The sine is 4/5, 0.6, 0.8. So now I need to decompose this force of 30 kilonewtons into an horizontal force and a vertical force, where this angle is alpha. So this one becomes 30 cosine of alpha, which is 18. This one becomes 30 sine of alpha, which is 24. So we can represent the structure again, but now with an horizontal force of 24, 18, 18, 24. Now the next step is to use equations of equilibrium to calculate the reactions. I can use as equations of equilibrium sum of horizontal forces, sum of vertical forces, sum of moments to some point A, and sum of moments relative to the hinge to either the left or the right. I'm going to use the usual convention for positive forces and moments. And now, horizontal forces, I have two reactions, Rxa and Rxb, and both of them to the left, so both of them negative. And then I have a force of 24 to the right and a force of 24 to the left. In terms of vertical forces, I have two reactions, both of them upwards, and I have two forces of 18, both of them downwards. In terms of moments, the only reaction that causes a moment relatively to A is this one. So RIB and a distance of 6 meters, and then I have all the other applied forces. The horizontal forces are applied at the middle of the beams, so 2 meters, and the vertical forces are also applied at the middle, and so 1.5, 1.5, 1.5, 1.5 meters. So let's start with the horizontal forces. I have a force of 24 to the left that causes a positive moment and at a distance of 2 meters. And then I have another force of 24 which goes the opposite way. So basically they'll cancel each other. Regarding the vertical forces, I have two vertical forces, both of 18, and both cause a negative moment. One of them is at a distance of 1.5, the other one is at a distance of 4.5. This equation has only one unknown, so it's relatively easy to solve, and the solution is RIB equal to 18 kilonewtons. The next step is to calculate sum of moments to the hinge to the right, and I need to take into account these two forces, this reaction that I already know, and this one that I would like to find out. So I have RIB, which is 3 meters away from C and causes a positive moment, and all the others cause a moment in the opposite sense. So RxB at a distance of 4, 24 at a distance of 2, 18 at a distance of 1.5. Solving this equation, I get Rxb equal to minus 5.25 kilometers. Now, since I already know one of the reactions, this is easy to solve. And since I already know the other vertical reaction, now I can represent everything in one go. So the two vertical forces are both 18. This reaction is 5.25. The horizontal reaction in B is actually the other way around, 5.25.